Okay, so I'm ready to move on to building up the circuit. And as I mentioned the last time, the first thing I'm going to build up is the power supply, which consists of these two 5-volt regulators. There's a 3.3 volt regulator. There's this polarity protection diode here, and there's a pile of filtering caps. Now, one of the things I've just noticed is these caps here are SMD tantalums, and I didn't order any of them. So what I'm going to do just to get this thing going is these are 1206s. I'm going to put some 1 microfarad caps in here, here, and here. That should presumably work okay. And then I'll order the tantalums separately and reinstall them when they arrive. So anyway, what I'll do is I'll get this all installed in, and then we should be able to test 5 volts right here, 5 volts right here too, and then finally 3.3 volts right here. So let me get that installed and come back. Move on, I'll just quickly go through where those components are on the circuit board. So here's the jack, the input jack for 12 volts. It's center positive. Here's the first of those electrolytic caps. This is the reverse polarity protection diode here. And then all the way over here, these are the two 5-volt regulators here. Here's the 3.3 volt regulator down here. And then you can see here C3, C4, C21 are where those tantalum caps are supposed to go. And like I said, I'll just put 1 microfarad caps in there just to get me going. Anyway, I'll build that up and we'll come back and test. Okay, so I've got all that on the board. One thing I forgot to mention, this is a PTC fuse here. Here's a pair of electrolytics that's in addition to the SMD components. Here's the two 5-volt regulators here and here. Here's the 3.3 volt regulator down here. And as I mentioned, I should really have 10 microfarad tantalums here and here. And I've just put in 1 microfarad. I will order the 10 microfarad tantalums and get them installed as soon as I get them. One final note, here's the reverse polarity protection diode right up here, and you'll see the stripers to the top. Okay, so let's just go around and measure some voltages. I've just got a little switch hooked up to H9, so I can sort of turn this off and on as I need it. So there we go, it's turned on. So let's just probe around. So I should see 5 volts on the output right here. Be careful not to short things. You can see there 5 volts. 5 volts also here. Sorry, it's hard to do this behind the camera. There's 5 volts. And then finally 3.3 volts right here. And there we go, 3.3 volts. So all the voltages are good right now. And we can move on to the next step. Okay, so the next step that I'm going to do is put in, so these two components are already installed. So this is the audio codec, this is the PSOC. So really all I need to install is all the filtering caps around these ICs. You can see here, I've also got to install the 24 megahertz crystal, the two 10 picofarad load capacitances here, and then over here we have the pull-up resistors for the I2C lines coming out of the PSOC, and then we've got a couple of 0.1 microfarad caps there. So I'll get all this installed. Now that also includes this diagnostic LED that I mentioned before, and it pulses Morse depending on various diagnostics, such as if it can't find the si570 and so on and so forth. So I'll get all this installed, including the LED, and when we power it up, we should actually see some flashing out of the LED. That will indicate that the microcontroller is actually alive. Okay, so let's turn it on, see what we see. So we got some flashing, so that's good. Means the microcontroller is alive at least, but let's see if we can decode that. So it is Morse. So let's wait for it to start again. So dit I, dit da da da, t 2. I missed the last one. So dit. So it's I2, da, dit, C. I2C. So that's an I2C error. So let me have a quick look at what that could be. Actually, I already know what it is. Well, I know what it might be is I haven't installed these two pull-up resistors, R48 and R49. Let me get those two installed right now. They're 4.99 K resistors, and we'll see if the flashing changes. Okay, so I got those two pull-up resistors installed here and here, 4.99 K. So let's turn it on and see what we see. My Morse is not very good, so you'll have to forgive me. So S, I, 5, 7, 3, 4, 5, si570. So that's obviously because I don't have the si570 installed yet. So this is good. So what this tests is the I2C connection from here to here is working. And the latest error message is that it can't detect the si570 synthesizer, which is true because I haven't yet installed it. So let me go ahead and get that installed, and then we'll come back and see if we get a clean bill of health on the LED. Okay, so that's the si570 installed. Note the orientation, so the writing is up, so this writing's right way up, and the writing aligns with the text on the circuit board. So the other thing I had to install is this 0.1 microfarad cap here, and so this I did use the hot air gun. Well, I've used the hot air gun with everything, but this is particularly tricky to install if you don't have a hot air gun. Now, I will include a link to a video that W2AEW did that showed how he installed this using a soldering iron. So I'll include that link. So let's move on to some testing. So just as a matter of interest, here's the actual code that's running on that microcontroller here. And here are the three error messages that's possible on startup. So basically, this error function blinks the LED in Morse with whatever characters are sent it. So there's this little Morse function here, which has all the encodings for all the dits and the dars. So anyway, you got three possible errors on startup. So if you recall, we were getting the I2C on startup. That was because the pull-up resistors weren't there. So when I installed the pull-up resistors, now we were getting that si570 error, and that was because the si570 wasn't installed. And then I haven't seen this error at all. I assume you would get this error if you didn't have the PCM3060 installed, or it was malfunctioning in some way. So anyway, this is the code that actually does the error output, and I thought that might be of interest. Now, as I mentioned, to compile this code, you have to have the Cypress, I can't remember the actual software name, but it's the Cypress development environment to actually compile and flash this code on the board. I might actually try that later. The development environment is free, I believe. I think it's free anyway. I'll have to check on that. The one thing that isn't free is the programmer. There's actually a programmer that comes with it that connects from your PC through to the in-circuit system programming header on the board. So anyway, I might have a go at seeing if I can flash my own version of this onto the board, but that'll come up a bit later, I think. Anyway, thought this might be of interest. Okay, so there's a default behavior of the si570, which is to output around about 56.35 megahertz, and the easiest way to probe that is this U14 here is the dual D-type flip-flop from which the Quadrature output is produced. So pin 3 is where that signal comes in from the si570. So I should be able to probe pin 3 here, and I should see around about a 56.35 megahertz signal. Now, what I might do is I will install U14 and after we've tested this, and then I should be able to see that Quadrature output there. So this is the D-type flip-flop. You also have to install this decoupling cap. But let's look at the source signal here and just confirm we're getting it there. Okay, so now when I turn the radio on, I get a solid green LED, which indicates that everything has started up successfully. So it's basically contacted the PCM 3060. Everything's good there. It's sent I2C signal to the si570. As I said, there's a default frequency output there, which we should be able to probe now. So let's get this on the oscilloscope and check it out. Okay, so there's that signal. It's a little bit messy, but that's probably to do with the way I'm probing it with my oscilloscope here. But you can see indeed that's 56.3538 megahertz signal coming out there. And it's a strong signal too. So like I said, what I'll do is I'll install now the dual D-type flip-flop, and then after I've installed that, we should see the output. Now the output will be in Quadrature, and it will be a quarter of this frequency right here, so around about 14 and a bit megahertz. So let's get that installed, and let's probe the output. So I thought I'd hit my first snag then for a moment. I installed an AC 74 in this U14 right here, and I was getting no output at all on the other side of it. So I swapped it out for another one that I had. I've got quite a few of these, and it does seem to work, although interestingly, the kit actually specifies ACT 74s, and the voltage, the kind of voltage ranges are different between the AC and the ACT versions. What I might do is, I don't have any ACT 74s. I'll order some ACT 74s, replace that in there, and make sure, make sure I'm sort of installing the right ICs that are specified in the bill of materials. But anyway, just moving on. So what I want to do now is just demonstrate that I'm getting a Quadrature output here. So what I've done is the output of U14 goes to two places. It goes to the transmit mixer side, and it goes to the receive mixer side. What I'm probing out here is the receive mixer. So that's that sort of Taylor mixer that we've seen before. Uses an FST 3253, as you've seen earlier. And I'm probing on pins 2 and 14 of that IC. So I should see a Quadrature signal, again, around about 14 megahertz. So let's go over to the oscilloscope and see that. Okay, so here we are on the oscilloscope, and you can see indeed we do have those two signals in Quadrature. A little bit noisy at the top there, but it's most likely the way I'm probing it here. And you can see exactly a quarter of the signal we're seeing before. If you recall, that was around about 56.35 megahertz. Now we're seeing a signal of around about 14.088 megahertz. So and that's I guess the default startup frequency for this radio. So let's just quickly summarize where we are, and then I'll probably wrap the video. So we've got the power supply circuitry installed here. Note that I did have to swap 1 microfarad for the 10 microfarad tantalum, but I'll get some of those and replace it on there. So we tested the regulators, all good, the 5-volt regulators and the 3.3-volt regulators here. We then moved on to the circuitry around the microcontroller here, and installed all those filter caps, as well as the 2 pull-up resistors for the I2C lines, and just sort of quickly swapping over to the other side so we can see that. here's a pile of filter caps that's associated with the microcontroller and the audio codec. We got the si570 installed there. You can see that's installed. This again all with a hot air gun. And then sort of going back over to the other side, installed this AC74, the dual D-type flip-flop. Signal comes in here on pin 3 from the si570, and we can see we probed pin 2 and pin 14 of U6 here, and saw that quadrature output at a quarter of the frequency that's coming in here. So off to a good start. What I'm going to do in the next video is get the USB. I've just got to find it. Where is it? Oh, it's over here. So get this USB installed. There's some protection circuitry on here. Because what I want to be able to see is there's some software that you can use to program the frequency. I want to be able to see that this should actually show up as a sound card when I plug it into the USB. So I want to make sure that's happening. But that's coming in the next video. It's a wrap for now, and I hope you enjoyed it. More to come.